All right, in my last video, we saw the RX 6800 XT make some shocking gains, at least in certain titles, like Forza Horizon 5 gaining almost 30% performance, and that's kind of mind-blowing. Although we saw in other titles very much less impressive gains. But one question I had is, I wonder if all AMD GPUs have the same percentage gains as the RX 6800 XT. And I haven't seen a lot of other channels, if any, actually test that out. A lot of smart access memory testing I've seen is just on one GPU, and that's what I did. So in this video, I'm gonna be looking at the RX 6600, and then I'm gonna compare the performance of the RX 6600 against the 6800 XT. And while obviously it's not going to perform as well as the 6800 XT, I'm curious if the percentage growth is at all similar to what we saw from the 6800 XT. But first, let me address something that came up in the comments all over the place in that last video. How do you actually turn on smart access memory? Well, first you do need to have compatible hardware. Officially, you should have a 500 series AMD motherboard with a 5000 series Ryzen CPU and an RX 6000 series graphics card. However, that has actually expanded beyond those settings. There are some 3000 series processors, 300 and 400 series motherboards, and I believe even the 5000 series GPUs actually having some ability to do smart access memory, but I don't know whether that would perform as well or in all situations as it is here on my test setup. That being said, if you are on a compatible motherboard, you also need to have a compatible BIOS installed. I say BIOS sometimes, some people say BIOS. I don't know, guys. Anyway, I'll probably alternate between the two just to irritate everyone. Anyway, so in your BIOS, you turn on resizable bar. You can see that behind me here. You need to enable that. Although on my motherboard, it actually has disabled and it has auto, where then it kind of auto detects if the rest of your hardware can support it. And where you find this can also depend based on what, motherboard manufacturer you have, what BIOS you're looking at. And so in mine, I find it under the IO settings, the in-out settings, and then under the PCI settings, then I could turn on resizable bar. Other motherboards might have it in different places, and also, like I said, even if you have a compatible motherboard and CPU, you might need to update your BIOS to a BIOS that does actually have this feature enabled. Now, just turning it on in the BIOS does not actually enable smart access memory. In your actual PC, you then need to, once you started it up, go into your Radeon software and go to the Performance tab, the Tuning tab, and then scroll down to the bottom where you'll see AMD Smart Access Memory. And then you need to be able to enable that. And once it's enabled, you're now actually using smart access memory. Now, I have had an issue where at one point I couldn't enable it, even though I'd been able to in the past. And the way I fixed it was actually going back to my BIOS. And even though it was on auto, which is what mine did for enabled, I had to actually disable it, restart the computer, restart it again, turn it back to auto, restart again, go back here, and then enable it. And then it did work again. So just so you know, there maybe could be some weird issues like that. But anyway, let's actually get to the benchmarks. So how'd the RX 6600 do? It looks like my fat head's in the way. Ah, good thing I can fly. Anyway, so how'd it do? Well, it did really well. There were major performance gains. And we can see that at 4K, the performance gain was very small. At 1440p, it was modest, but definitely noticeable. And at 1080p, it was fairly large performance gain. However, if you're thinking back to my last video with the 6800 XT, wasn't the 6800 XT a little bit more impressive? And I would say, yeah, we were jumping from 86 to 103 at 4K, from 110 to 142 at 1440p, and 124 to 161. And if you just look at the sizes of the bars compared to each other, it might make you think that the 6800 XT was getting a larger performance gain percentage-wise, as a percentage of FPS. And yes, and it looks like I'm in the way again. Now I'm tiny. Look at that. Again, the magics of green screens. All right, oops, clicked too far ahead. But anyway, you can see the percentage difference here. So that's what I'm measuring in this graph. Be very careful, I changed up what this is measuring. This is no longer SAM off and SAM on. This is the 6600 and the 6800 XT. And these are not frame rates. This is the percentage gain I got by enabling SAM. Okay, so this is using the previous slide data, dividing SAM on by SAM off to get a number, right? So at 4K, for example, the RX 6600 was getting a 2.3% increase in performance by enabling SAM, whereas the 6800 XT was getting a 19.8% increase at 4K. And again, a 12.1% increase for the 6600, which is a huge increase. That's significant. But the 6800 XT was getting 29.1%, and at 1080p we saw 13.6% gain for the 6600 and a 29.8% gain for the 6800 XT. So it's actually really interesting here. While both of them do better the lower the resolution goes, both of them did gain significant performance. It's also true that the 6800 XT gained a lot more as a percentage. Now, I'm wondering if you looked at this in terms of the actual amount of milliseconds that were cut off per frame, maybe we'd see something more interesting. It's hard to say because my 1080p results here went from 81 to 92. The 4K results on the 6800 XT went from 86 to 103, which are at least sort of comparable type numbers. It's a little bit higher. But if I compare the percentage gain I got on the 6600, that was 13.6 compared to the 19.8 we got at 4K on the 6800 XT. So I think there's a little more to it than just if you're at a certain frame rate, it gives you a certain percentage. Although, to be honest, I didn't explore that maybe as in-depth as I could have. However, let's go ahead and check out how this did in other games. So jumping into Cyberpunk 2077, and this is using the in-game benchmark that was introduced with the 1.5 update. I again tested it out at ultra settings, 4K, 1440p, and 1080p in order to match the testing environment that I used on my 6800 XT, and saw only the tiniest gain at 4K, again, absolutely tiny gain at 1440p, and a probably imperceptible to the actual eye difference at 1080p, although it is technically a positive gain. This is free performance by just clicking a button. The 6800 XT had much more noticeable differences, although again, these actual frame rate differences, you know, you'll notice them on a frame rate counter. How much would you feel that difference while playing? That's debatable. And if we look at it in terms of percentage gain, once again, you know, a 7.4% percentage gain in frame rate might be kind of noticeable. 3.1% on the 6600. Again, this is the 6600 and 6800 XT percentage gains now, right? Just to be clear what we're looking at. It's definitely a lot less noticeable on that 6600. Both of them are free performance though. Let's go ahead and move on to Total War Warhammer 3, where just like with my 6800 XT, the performance gains here were, I mean, I guess they exist, but you would not notice it unless you were running a frame rate counter. And that's about all I have to say. The 6800 XT was in a similar position, although once again, if we do actually compare the percentage growth, well, the percentage growth here is basically nothing for either card. It is technically higher on the 6800 XT. All right, with Horizon Zero Dawn, we once again see some actual reasonable percentage gains here. We wouldn't really notice it at 4K, but you might notice it at, 1440p, maybe just in the 1% lows. And that was something that people wanted me to add to these charts, and once again, I didn't add it to the charts here. Like, honestly, guys, I do this in such limited free time as a math teacher with a family, and like, the only reason I got this videoed out with all this more testing done was because I had President's Day. So I got a day off of work. Anyway, but like an average of 60 at 1440p does mean that you're dropping below 60 at times. And this did actually help pull those minimums up closer to 60, which would be nice, especially if you didn't have a variable refresh rate monitor. So I think while it's modest gains, it could be noticeable. And again, at 1080p jumping from 81 to 87, which is at least nice. Now the 6800 XT once again had larger gains at every resolution, and if we measure it in terms of performance, Again, both of them actually, I think, do quite well in this game. Like a 5% gain at 1440p is great. A 7.5% gain at 1080p is great. Honestly, even comparing this to just like overclocking or something like that, it's hard to get a 7.4% gain on terms of overclocking, but once again, the 6800 XT is actually giving a 10.7% gain. Now, that's kind of a side note too, is I'm interested in how this would interact with overclocking. But let's look at Red Dead Redemption 2 as my final here. And we saw, again, almost imperceptible gains. They are very small. The 6800 XT had gains that were actually somewhat noticeable. Whether you'd notice them in actual gameplay, who knows? But like, you know, at 1080p at least, 108.9, you know, 8.9% growth is great. 1.9% growth, hey, at least it's better performance, right? And then the last thing I want to mention is Red Dead Redemption 2 is a game that when Hardware Unboxed tested out Smart Access Memory, they were actually, instead of seeing just a small growth, it looks like when they tested it, they were actually seeing, and by the way, they were using Vulkan, so was I, they were seeing -1%. Whereas if we look at, for my two cards I just tested here, you know, at 1440p, which is the graph I have up here from Hardware Unboxed, even my 6600, which was kind of underwhelming, I was still gaining 1.3%, and my 6800 XT gained almost 5%. And, you know, 1080p did even better. Now, what could be going on with this? Well, Hardware Unboxed did their tests over a year ago. I think this, or at least around a year ago, was the time they made this video. So unfortunately, I don't actually have these other games installed right now to test, but I'm also curious if some of these other games that used to lose performance with Smart Access Memory either don't lose as much now, or maybe even actually have modest gains instead of performance loss, as I was seeing here with Red Dead Redemption 2. Be interesting for further study. Maybe I will have time to do that myself. I honestly don't know, guys. Other things I'd like to test out in the future, maybe I'll have time, maybe I won't, is how this interacts with overclocking. Because I'm curious if somehow you would impact the stability of your overclocks. I honestly have absolutely no idea if it makes any sense that that would have any difference. And also how much performance gain you're getting from an overclock. So in other words, what if we compared stock and no SAM with stock with SAM, and then OC with SAM, right? And then like, you know, no SAM but with OC. And if you compared all those, and I'm just curious what might happen. I'm also interested in comparing NVIDIA's resizable bar support. And I do actually have an RTX card on the way for the channel to do some more testing. All right, hopefully this video was interesting and or informative, maybe both. And I hope that you have an excellent day.